All right, I'm gonna make a video going over 8.2 part 2. So here you go. Some of these I covered in class already. Question number 1. Figure below represents a unit circle. What's the cosine of A? What's the sine of A? Cosine is always going to be the x value. Sine is always going to be the y value. So cosine will be 1/2. And sine will be negative square root of 2. Next. Question 2. What is the sine of 2 pi over 3? That's a radian. So to get a radian, we want to make that into a degree. So we're going to do 2 pi over 3 multiplied by 180 over pi. That's 120 degrees. So we're going to do sine 120. And that's 0.866. That is the square root of 3 divided by 2. 0.866. Question 3. What is the degree measure of 9 pi over 5 radians? Like the last problem, you can convert 9 pi divided by 5 to a degree by multiplying by 180 over pi. 324 degrees. Number 4. On the unit circle, the ordered pair xy represents the point where the terminal side of theta intersects the unit circle. If the measure of angle theta is 5 pi over 4 radians, what's the single coordinate at angle theta? So we can do this. The unit circle is x squared plus y squared equals 1. We want to know 5 pi over 4 as a degree. So we'll do 5 pi over 4 multiplied by 180 over pi, and that's 225 degrees. Next, remember that cosine is x, sine is y. So we can create a coordinate, parentheses, cos a, or 225, excuse me, comma, sin, 225. We can label that, and we can see that coordinate is down here. This is 90, 180, 270. Halfway between there is 225. Notice that they're both the same, quadrant 3. So they're both going to be the negative square root of 3 over 2. Excuse me, negative square root of 2 over 2. So negative square root of 2 over 2 for both. That's in quadrant 3. Next question, number 5. On the unit circle, the ordered pair xy represents the point where the terminal side of theta intersects the unit circle. If the measure of angle theta is pi over 4, what is the coordinate at angle 0? So angle theta. So pi over 4 is 45 degrees. And cosine of 45 is square root of 2 over 2. Sine of 45, square root of 2 over 2. Notice that they're both the same. If you look at where that is on the unit circle, that would be right there. Let me blow that up a little bit. And that's in quadrant 1. And they're both the square root of 2 divided by 2. Square root of 2 divided by 2. They're both the same. So the idea behind the next question is just getting you to think about it. Where do the sine and cosine equal each other? Well, that both occurs in the 2 quadrants we were at. So just kind of looking at the unit circle again, x squared plus y squared equals 1. And what you can do is you can say cosine A Watch this. Do parentheses. And sine A. We're going to add a slider, and we're going to make our slider go from 0 to 360, and we'll count by 15ths. And so if I move that up here, let me label that. Look at the x and y value. They're both the same here, like we just did. And they both become the same. They have the same decimal, but they have different signs in quadrant 2. But in quadrant 3, same negatives. And then quadrant 4, opposite signs, again, same decimal. So they're going to be the same in quadrant 3 and quadrant 1. That's where cosine and sine equal each other. And they're both square root of 2 over 2, or negative square root of 2 over 2. So quadrant 1 and 3. Question 7. In the diagram below shows an angle theta graphed in xy coordinate plane. Segment RT is the initial side of the angle. Segment RM is the terminal side. Segments RT and RM are radii of the unit circle centered at origin R, 0, 0. The x-coordinate of point M is -1/2. What's the measure of theta to the nearest thousandth of a radian? So let's go ahead and graph this unit circle again so I can we can understand what's going on. So we're going to do x squared plus y squared equals 1. And I want you to think about where this is. Okay, this is 180, this is 270. So it's somewhere between 180 and 270. So let's go ahead and do our coordinate. Cosine A, comma, sine A. Add the slider. Make it start at 0, 360, and we'll count by 15. This works every time. So if you move that up here where, let me click label on there so you can see the coordinate. Right there, it looks like about where we are. Notice that the x value is -1/2 and the y value is the negative square root of 3 over 2. Well, this does say the x value is -1/2. So now we have our degree, it's 240. This question wants to know, what is the radian to the nearest thousandth? So we get a radian by saying degree multiplied by pi over 180. And we're going to incorporate pi into this one because it wants a decimal. So we say 4.189. Next question. The diagram below shows an angle theta graphed in the xy coordinate plane. It's the same description. The angle's changed. We want to know what that radian is. Now, if I look at that, that looks like it's between 90 and 180, right halfway between. So if I were to do the add 45 to 90, that's going to give me 135. We can test that out. So I'm going to go ahead and graph it again. Remember, cosine A, comma, sine A. Add slider, 0, 360, 15. Zoom in a little bit, and let's move it. Let's label that up. And notice that they're both -0.707, negative 0.707 and 0.707. That is the same thing as the square root of 2 over 2. The y coordinate is positive, so that's correct. So now we have the degree, and that degree is 135. So let's get the radian. And the radian's about 2.356. Next. Number 9. The diagram below shows an angle theta graphed in the xy coordinate plane. Segment RT, same description, different angle. We want to know this angle. So again, look at this, where this is closer to the x-axis. So it should be about 30 degrees from 360. So I'm going to guess 330 degrees. But we want to know the x-coordinate is the square root of 3 over 2. And we can always verify that with graphing it. So x squared plus y squared equals 1. Parentheses, cosine A, comma, sine A. Add slider, 0, 360, 15. And let's move it. We'll label that. So it looks like the x value is the square root of 3 over 2. The y value is negative 1/2, so that's right. So 330 multiplied by pi over 180, 5.759. So I'm going to round that up to 5.76. 5.76. All right, I'll make a separate video for the rotations.